Good afternoon, everyone, and a very warm welcome to today's webinar on how to use durable carbon removals to reach your climate goals. I will just let us have a few seconds for everyone to join to make sure that everyone gets in. But in the meantime, my name is Emma Rehnberg Jensen, and I will be hosting today's webinar. I work as an account manager for our climate solutions here at Atmoz. And with me today, I have the pleasure of having two of our project partners, which is Thoralf Guterres from Sirona, which is a direct air capture technology performing carbon capture and storage. And we also have Peter Gunning from O.C.O Technology, an Accelerated Carbonation Technology performing carbon capture and utilization. So thank you so much for being here today, as this gives our audience a rare and unique opportunity to get valuable firsthand insight. Welcome to both of you.
Thank you.
Thank you.
So I hope everyone is here by now, and I will move on. And just before we get into everything that we are covering today, I wanted to share a quick overview of our agenda for the next 45 minutes, which is as follows. For those of you who are not yet familiar with Atmoz and our full offering, I will start off by introducing us briefly. Then we will explore how CDR fits into your climate strategy and the beyond value chain mitigation framework that has been presented by the Science Based Target Initiative. I will then be joined by Peter and Thor, who will be presenting each one of our two portfolio CDR projects in depth, followed by a conversation about durable carbon removals. At the end of the webinar, we will have some time to answer questions from the audience. So please do feel free to use the chat function to ask any questions you might have. And as of house rules, this webinar is being recorded and you can be given access afterwards. And as mentioned, please do use the chat function to check during, pop any questions, because that is the only place we will be checking during our Q&A. And should you have any questions after the webinar, you are obviously very welcome to write them down in an email. I will be sharing contact information at the very end. So what do we actually do at Atmoz? Atmoz offers end-to-end carbon management solutions ranging from emissions calculation to offsetting. We've developed an intelligent platform that integrates directly to existing ERP systems, collecting the data automatically and transforming it into scope 1 to 3 emissions data. Our calculations align with the GHG protocol and are done all within minutes. But as we know, we can't get all the way there without having unabated emissions just yet. And therefore, we also help our clients finding the right offset project or project portfolio to match their needs. Now, when it comes to carbon offsetting, we've been operating in the voluntary carbon market for 10 plus years and have helped our clients avoid or remove 2.5 million tons CO2. At Atmoz, we do advocate keeping carbon offsetting as a complementary strategy. While offsetting contributes to the solution, companies should not lose their focus on achieving direct emissions reductions within the company's operations and value chain. So the way Atmoz supports organizations in their carbon offsetting strategy is by facilitating offsets beyond companies' direct value chain. We offer credits that align with the BVCM framework recommended by the Science Based Target Initiative. And as we've been in this field for quite a few years, we have formed strategic partnerships with project developers around the globe. This means we have a global reach of high integrity credits offering both avoidance and removal credits from nature-based and engineered solutions. The BVCM framework guides companies on how they can take responsibility for their yet unabated emissions whilst they're on their journey to meeting their reduction targets. Setting targets is a very efficient way to reduce global emissions, but as we have already, as of last year, exceeded the 1.5 degrees threshold in the global warming, we are also in great need of actions and solutions that reduce our global emissions even further. We can't simply rely on future solutions or targets that shall be met 2050. Therefore, the BVCM framework has stated two main goals when it comes to mitigating emissions beyond your value chain. And these two goals are, one, to deliver additional near-term mitigation outcomes to achieve the peaking of global emissions and the halving of global emissions by 2030. And two, to drive additional finance into the scale-up and nascent climate solutions and enable activities to unlock the systemic transformation needed to achieve net zero by mid-century globally. This means that companies can essentially build a BVCM portfolio of avoidance and removal credits to deliver on these two goals. And as shown in the graph by SBTi themselves, you can see how the BVCM amount of those mirrors the amount of unabated annual emissions. And they do recommend companies to start early to secure CDR credits to be able to meet the final net zero target. Reasons being, one, to ensure that you can actually access these CDR credits, and two, to get it into your budget as CDR credits are higher in cost. And lastly, also to be able to offset all of your residual emissions with permanent carbon credits by 2050. And the reason why it is important to start early is furthermore the fact that CDR credits are limited in supply and we experience a rapidly increase in demand. So as mentioned and aligning with this, Atmoz offers a selection of credits in our portfolio. So we have got both nature-based and engineered solutions and avoidance and removal credits. And today we are deep diving into our engineered removal projects. So with no further ado, it is time for our two projects, CDR project partners. As mentioned, we have got Thor, CEO and co-founder of Sirona, performing DAC, which is short for direct air capture, and Peter Gunning, Sustainability and Technology Director at O.C.O Technology, performing ACT, Accelerated Carbonation Technology. Thank you so much for joining us today. You represent two very interesting methods when it comes to CDR. Thor, your technology is a CCS technology, meaning you capture and store the carbon as your permanent solution, whilst Peter at OCO, you use CCU mechanism, meaning you utilize the carbon to produce another product. And this actually works as your storage mechanism. So for everyone to understand how it works in practice, we are going to let you guys walk us through your technologies, starting with Thor and Sirona. Thor, please go ahead.
Thanks a lot. Thanks for taking the time, everybody, today. I'm looking forward to presenting what we do at Sirona. So we are a direct air capture technology. And maybe before I talk about that, I'll just give you a few words on my background. So I'm Thor, based in Belgium. The whole company is based in Belgium. So we are a European project. I'm pretty happy to be building these machines here. My background is that I'm an engineer. I used to work at Tesla before starting the company here in California. Very controversial company these days, but I learned a lot, especially in terms of the engineering principles required to scale hardware. And that's really the mindset that we're applying at Sirona Technologies to this carbon removal space to scale direct air capture. So I'll talk to you a bit more about what we do and the project that we have. So if we go to the next slide, what you see here is our direct air capture technology in the background with the team in the foreground. So our technology removed CO2 from the air, right, from ambient air. So we don't do point source capture, we do from ambient air. And we particularly like doing this with machines. If you go to the next slide, a few different reasons. What we really like about removing CO2 from the air with machines compared to other methods is going to be the scalability of the solution. For example, if we look at all the CO2 that we will have to remove from the air in the coming century, if we were removing all of the CO2 with forests, we would typically have to build a new forest the size of Asia, which is going to be hard. We should do as a society as many forests as we can because there are plenty of other co-benefits that come with that as well, including biodiversity. But we also know that forests are not going to be enough. And so that's why we designed these machines to remove CO2 from the air using less land, especially without competing with arable land. The second is that the CO2 that we capture with our machines, we will then provide to a partner, and our partners are going to inject the CO2 on the ground for permanent storage. So they will drill a hole 800 meters deep to store the CO2 permanently. And that's important, especially when you're thinking about how can I compensate fossil fuel emissions, is you want to make sure that the capture and storage is done in a durable, permanent way, because the fossil fuels are going to stay in the air for a long time. And the third aspect is the verifiability. It's very straightforward to track exactly how much CO2 has been removed with our machines, which really helps preventing any kind of reputational risk that you may have if it's not extremely clear exactly how much impact on climate has happened. And then if we go to the next slide, the way that we implement our technology then is by retrofitting shipping containers. So we modify them to put our machines inside, and the containers become the machines themselves. As you can see here on the picture, these systems are then very modular and plug and play, meaning that we build them in our manufacturing line here in Brussels, and then we ship them to our project where we will deploy the machine so they can capture CO2. And when we deploy them to the site, there's no or very little work to be done on site. The machine just works, right? You plug it in to your energy inputs, to your CO2 output, and it just works. And this is important because it allows us to start very quickly, meaning the moment that we have one first container that is ready to go, we can ship it and already generate revenue and generate value to customers like you. And then second is it really helps us iterate quickly on the technology because we can improve the technology every time we build a new container. And then we then deploy these containers to our site where we just add more containers over time to increase the capture capacity of our plants. And then if you go to the next slide, we then deploy these machines to the world and we look for two different things. We look for places where there's an abundance of clean energy and where we can store the CO2. And so the first project that we have is in Kenya, where we already have a pilot plant that is deployed, where the machines are going to be powered by typically geothermal, hydro, and wind energy. For the pilot plant here, we use solar because it was actually faster to get something up and running. But as we scale, we will co-locate typically with geothermal power plants, which have excess energy in Kenya that they have to curtail today. And so we can leverage that waste energy and to run our machines. And then the CO2 gets stored in the basalt rock in Kenya. So they have these rock formations that are basalts, very similar to Iceland, that is ideal for CO2 storage. And doing these projects in Kenya is very interesting because actually the country is very excited to see a lot of economic development. And they currently have too much clean energy. And so they're very happy to sort of use the natural endowments for direct air capture and then bring that economic development to the country. And so we spend a lot of time also with local communities to understand how we can help them with the project, including access to water. And the second project that we have, if you go to the next slide, is a project in the UAE, where we are powering the machines using solar farms in the region and then storing CO2 in a different kind of rock formation called peridotite rocks. And this is our most advanced project right now, where we are actually commissioning the commercial plant, and we expect to deliver our first credits in the coming months. The project in Kenya is taking a bit longer on the storage side, and so we expect our first credits to be delivered in the second half of 2026. But this one is already starting operations right now, so we're very excited about that. We'll be the second DAG company in the world to have ever delivered certified credits after Climeworks. And if you go to the next slide, this is a brief summary of the different projects that we have. Kenya, I showed you, UAE, and we also have another project in Norway, which might be interesting for folks in the Nordics, especially if you're looking to invest in projects that are closer to your operations, that help you tell a more compelling story to your investors, to your employees, or to your customers. We will also deploy technology in Norway, where we can have access to hydro energy to run our machines, and where we can store the CO2 in the North Sea with Northern Lights. And so this is a developing project that with which we also expect to have a pilot plant running in the second half of 2026. So happy to discuss that project with some of you if that's what you're interested in. But if you're interested in credits in the short term, where you have very low delivery risk, then it will be looking at the UAE. But if you're looking for projects with co-benefits, then you would be looking at Kenya. And then if you go to the next slide, we already work with a number of leading companies, including Shopify, but also a very large private equity fund in Sweden that some of you might guess who it is. And then IMC, which is a global trading firm based in Australia, EXA, which is a B2B startup studio actually in France, and more. If you go to the next slide, the way we typically work with companies through partners like Atmoz is to have contracts that are either one-off, where you in the beginning might decide to do a small amount of volume to get your feet wet and to start to get to know us and understand if how well we will deliver. And then once you feel comfortable, already now, if you're ready, would be to do a multi-year offtake, where you can buy a set number of tons for different vintages over the future. In each of these options, always, we're very open to do payment on delivery. So you don't spend the money right now, but you spend the money once we deliver. And then I don't actually know how Atmos deals with the interface there. So it could be that it's different for Atmos, but that's basically how we work on our end. And then we have a third option, which is also open to discussing with Atmos as well. But like, if you don't really know what your strategy should be, we can propose options for perhaps 5% of the contract value, where you could lock in a volume at a given price in the future, and then you get to decide later on whether you want to purchase them at that price or not. And I think that's all I had. So looking
You
forward.
have
Yeah.
one more slide here. I don't know if you want to go
This is
through that one.
This is the appendix, which is basically how does technology work. I think we can skip it. Yeah, you can skip it. Sorry about that.
All right.
Great. I'll let people talk.
Thank
Looking
you
forward
so
to your
much.
questions. Thank you.
Yes. All right, then thank you, Thor, and let's welcome Peter instead.
Thank you, and thank you everyone for joining this session. So I'm representing O.C.O Technology. We are a UK-based company. If you can move to the next slide, please, Emma. So I know we don't have much time, but I just briefly want to give you an introduction to our business, and then walk you through our carbon methodology, and then just lastly, just touch on some of the customers who we've been helping with their carbon reduction and net zero journeys. Next slide, please. So a common question we get asked is, well, what does the O.C.O part in the technology mean? And so I think unfortunately my animation hasn't worked very well here, but it's a stylized version of a carbon dioxide molecule. So it's an oxygen, a carbon, and an oxygen. Next slide, please. The business, this diagram just neatly represents what we do. So we will explain essentially we do three things. We recycle industrial waste, we capture carbon, and we make sustainable construction products. Those wastes can come from a variety of sources. So predominantly in the UK, we process the residues from energy from waste plants, but we can also take in residues from biomass energy production, cement byproducts, steel byproducts, and many others because they're all naturally reactive with CO2. We add water and CO2 in a controlled amount, and we mineralize the carbon into a form that we call manufactured limestone. In the UK, we produce a construction product in the form of a rounded pelleted aggregate that can be used in concrete, asphalt, and many other applications. Next slide, please. Okay, so this just neatly just explains that in a bit more detail there. So we've got our reactive waste materials, we had the water, and we had biogenic CO2, and I'll speak a bit more about the sources of that CO2 a bit later on. And you can see there a picture of the manufactured limestone. So this material can be made to different sizes, so typically in the region of 10 millimeters to 50 millimeters in diameter, depending on the type of application we're making it for. And then at the end there, you can see the sort of types of products that our customers then use it to produce. So it can be used in roads, it can be used in buildings, it can be used in foundations, those sorts of things. Next slide, please. So we're still a relatively new business. So we've been around for about 15 years now, with quite a long period of development, university-based prior to that. We currently have 3 operational facilities in the UK, and you can see on this slide, this is our facility near Bristol in the west of England. You can see that the key elements of the process here. So we've got the trucks that are bringing in the waste, which is in a dry powder form. That's then transferred into the large storage silos that you can see in the middle. And then the main process building is over there on the right. So that's where we would add the water and the CO2 and turn it into the manufactured limestone. So we currently, across those 3 facilities, we recycle around 250,000 tonnes of industrial waste per year. And since we've started, we've recycled well over 2 million tonnes. And because of all the mass balance, approximately 1 tonne of input waste equals 2 tonnes of product coming out. So that equals about 4 million tonnes of manufactured limestone. The UK is well established now, so a lot of my focus now is on our international developments, and I'll talk a bit more about that later. Last year, we were also extremely proud because we won the King's Award for Sustainable Development. Next slide, please, Emma. And again, please. So just this slide, I just want to walk you through our methodology, and I've tried to summarize probably a 100-page document on a single PowerPoint slide. The key elements here, starting from the left-hand side. First of all, we start off, of course, with a life cycle assessment. We use a piece of software called One-Click LCA. And we build our model based around a conventional cradle to gate model, or an A1 to A3 model, if you're familiar with these things. So we factor in the energy, we factor in the transport of raw materials to our site. We also factor in, of course, the CO2 that we absorb, and also the embodied carbon in any of the ingredients that we use, including the CO2, of course, because there is an energy penalty there to liquefy the CO2, but I'll speak a bit more about that on the next slide. So once we've built that, that's just, of course, just one piece in this big puzzle. So then we have to consider our baseline, and these waste materials, if O.C.O were not recycling them, they would be going to landfill. So effectively, their reactive capacity, their ability to absorb CO2 from the atmosphere would be lost forever. These materials are going to be placed in a hole in the ground. They're going to be covered over. They're going to have minimal interaction with the atmosphere, so that CO2 capturability is lost. In terms of additionality, I'm not going to lie to you, it's not a cheap process, but equally all the profits that we make, we constantly reinvest, and that is the revenue we generate from carbon is really fueling our international development. So that's the work we're doing in Japan, Australia, and America. In terms of permanence, we're mineralizing. So we're turning CO2 into rock effectively. So the likelihood of that being reversed is very small. Only if the material is exposed to high temperatures or strong acids is that CO2 going to be released. In terms of testing, we directly test the finished manufactured limestone. So we don't base our removal calculations around stoichiometry or flow rates. We actually take samples of the finished product and we test it for its carbonate content. So that way we can be 100% sure of the CO2 that we've removed. And then, of course, we've got our MRV elements there. So we use Alcove to manage all the data. There's a lot of data to manage. And then we work with Puro Earth as our registry. And then finally, verification through 350 solutions. So there's quite a few steps we have to go through to generate those credits. Next slide, please, Emma. Okay, so CO2 sources then. So in the UK, our model is to build large regional treatment hubs. So we've got the 3 facilities and they are taking in lots of different waste materials from different industrial facilities in the local area. So we need to bring CO2 to our site. And the only realistic way to do that at the moment is to bring in liquid CO2 in tanker trucks. And that CO2 is coming from biogenic sources. So our 2 primary sources are, as you can see in the top left there, anaerobic digestion. So that's farm cropped AD. And on the top right is a distillation process. So there is a whiskey distillery up in Scotland, and together with a company called the Carbon Removers, they capture the CO2 and deliver it to us. But we've also been developing new technologies. So we have a partnership with a company called O.C.O Technology. So you can see in the bottom left there, this is a direct air capture system, much like Sirona. This is actually a pilot plant that's been installed at one of our sites in the UK. It's just becoming operational. So that will be capturing around 1 ton of CO2 per day when it's fully operational. But it is scalable. So we could see a situation where we could be co-locating these DAC facilities alongside our facilities to provide the CO2 we need. And then finally, bottom right there, we've also developed a system whereby we can take CO2 from flue gas. So we can strip CO2 directly from the gas with minimal amount of gas processing. Next slide, please. And again, sorry. Okay, so conscious of time. So just quickly then. So in terms of our growth trajectory, it's exciting because next year our first European plant will become operational. And then in the years to come, we see further plants in Europe. But more excitingly, we're going to be seeing plants in Australia become operational, Japan, and also the big growth area for us is America, where we're partnered with a large energy from waste company, and we'll be looking to deploy our technology across the country. Next slide, please. Okay, and then lastly, just some of the people who we've already been working with. So some big names here, like Microsoft, Boston Consulting Group, and many others. So we're working with those to help them with their carbon reductions and their net zero journeys. So yeah, thank you for listening, and I look forward to any questions you have.
Thank you so much. And thank you both for this in-depth presentations. Now I have a few questions for the both of you before we open up for our Q&A. And for anyone wondering, I just want to say that Sirona, you're currently listed on Isometrics, and O.C.O, as you mentioned, Peter, you're certified by Puro. We don't have time to go through these certification processes today, as they are heavily technical and thorough methodologies. But they are publicly available on the registry website. So if you are interested in taking more insights in these, I recommend you to go and look through them. Now, Thor, you have this plant that's being shipped, or actually already is in the Middle East. What happens next? Do you need people on site to operate it, or is it self-sufficient?
Yeah, no, for sure. So most of our technical team is currently on site, commissioning the systems and and turning them on and validating all the different parameters before we start actual commercial operations where we will be um, capturing and storing and setting credits. And we are hiring basically a local team to run these machines, but you can expect pretty, yeah, like some babysitting and people on the ground to make sure things run properly with support from people in Belgium.
Are they easy to run?
Yeah, I mean, the goal is that they're plug and play, right? So
Right.
it's basically you've got an operator on his computer, and he presses play, and it starts running. And then, of course, it's our, yeah, the reality is probably going to be a bit more complicated as this is our first commercial, production operation. There will be maintenance windows where we'll be able to check that the components are continuing to run as expected, and that we'll be able to make some changes if we wanted to. I think it's also going to be interesting for us as the weather over there is quite different, is that we will be optimizing the different process conditions and understanding, how long do we adsorb, how long do we desorb, what are the flows, what are all the different things to make sure that we reduce the cost over time.
Yeah. And that actually leads to another question that I had. What are the optimal circumstances for in installing, like in terms of geographical location for installing
Yeah.
one of these plants?
So the benefit of direct air capture is that there's CO2 everywhere in the air, and it's really well spread out and homogeneous around the world, and so you can really go in the middle of nowhere as long as you have access to clean energy and CO2 storage. And
Mm,
so in the very far future, you can imagine you're in the middle of nowhere, middle of the desert, and you're just running off of solar and batteries and injecting the CO2 underground, right? That's basically everything that you need. And apart from that, there's also a lot of considerations around the weather and basically whether it's hotter or colder is going to have an impact on the chemistry of the filter we have in our machines. And so that is going to sort of guide where we go. If it's very cold and it freezes a lot, it might be problematic. And so you always looking for the right place. So for example, in Norway, where are looking to go is closer to Bergen, where
mm,
actually the Nord Stream is providing quite moderate temperatures and it doesn't freeze that often. And so it shouldn't be that much of an issue.
right. Very exciting. And Peter, you said that you are quite new, but that yet you are you're a few years ahead of Sirona. Um, how I'm curious to know the main changes that you've been able to see in the market compared to then 15 years ago.
Yeah, I mean, it's been quite profound, the change we've seen in that time. And interestingly, when we formed O.C.O, the idea of carbon capture was a secondary benefit. We were
Mm,
actually formed with the ethos of recycling waste. So it's completely flipped around really, and everyone's now focused on the CO2, and the waste recycling element is the secondary element of the business. But I think one of the things, probably the most profound change, has been probably the change in attitude to waste-derived products. And when we first started, there was quite a lot of hesitance and almost resistance in a way regarding the use of recycled waste products because they were almost regarded to be sort of secondary substandard almost. But that's now changed. People want these materials, which is really great. Unfortunately, it doesn't mean that people want to pay more for them. But can't have everything.
And can you use it for anything, this material, the product that you actually produce?
I wouldn't say we could use it for absolutely everything. I mean, every product will have its sort of its I suppose limitations, its target applications, but it can more or less be used as a direct replacement for natural aggregate in most applications. So things like concrete and road construction, general sort of earthworks and fill materials.
Right. Um, and I would like to touch up on co-benefits for both of you, because I know that as you're being certified, additionality is a must for both these certifications. But if we're touching on co-benefits, what are the co-benefits for each one of your projects? Peter, if you want to go first.
Well, I suppose on the additionality aspect, firstly, I touched on this. It is quite a challenging area, and I think we've addressed that clearly by demonstrating that we are reinvesting funds into new builds. And equally, one of the challenges that we have is around competition from conventional landfill. So that revenue is key. It's a key source for us in order to maintain the business and to maintain that growth trajectory.
Thank you. Or what about Sirona?
Yeah, so I think I briefly touched on it, but the way to think about direct air capture is that it's uh, top marks on additionality, on carbon accounting, on verifiability, on permanence. Um, and usually what that comes with is just no co-benefits at all. It's kind of like the purest carbon removal without any of the bells and whistles that you'll see on the side. Mhm. But what we found is actually in Kenya, you can actually have pretty strong co-benefits. Just to give you a bit of the story, basically, there's a company called Dalberg, does a lot of consulting for developing countries and governments in those regions and in the global south. And they were working with the Ministry of Energy in Kenya, which was really struggling because they basically overbuilt for their electricity production in the country. And so they built what they have now 3 gigawatts of electricity production capacity, and it's 90% renewable. It's like geothermal power plants, hydro, it's wind, but there's only 2 gigawatts of demand. And so they the economic growth hasn't been as big as they thought. And now
Mm,
they're kind of stuck because the folks who are paying for the 2 gigawatts of demand that is paying for the 3 gigawatts of production capacity, they're paying a very high price because there's not enough demand. And so someone needs to pay for the capex, and so it's the people who the few that are consuming who are. And so they're kind of stuck because the energy prices are high. Nobody wants to move to Kenya to do high energy industry. And so they were trying to figure out how to get out of this conundrum. And then they realized that they actually had all the ingredients necessary to do direct air capture at scale, meaning they had the land, they have a lot of, arid land that nobody uses, where there's nothing growing, there are no people that are living, and they have the right geology for CO2 storage, and they even have the geothermal systems to provide heat to companies like us, because actually our technology mostly needs heat, low temperature heat. And so we can co-locate with these geothermal power plants. And so they were like, we have all these things that are exactly perfect for direct air capture. We need someone to come in to consume the energy to bring the prices down for everybody. And so they basically, send the message out to the world uh, through this guy called James Mwangi, who's kind of the ambassador for this idea. And he had a TEDx about it, and like Kenya is the best place to do this. And so basically, the country is really welcoming us, with arms wide open, because it's going to help with their energy infrastructure. But then, as I mentioned, also, you're actually bringing really strong jobs, like engineering jobs, to a country that is lacking these jobs. And so we see a bunch of terrific engineers coming out of school, but there are just no jobs for them. And so you
right,
bring jobs to a country that needs the jobs, I guess, more than, the EU or the US. And so
right,
in that sense, you've got strong co-benefits there. And then separately, you also engage with local communities that are really around your site. Um, and we do it because we want to do things right, but actually it's also mandated with local regulations. If you want to have your environmental permits, you need to actually engage with local communities, get their approval, and make sure your project is also benefiting them in some way. And so, for example, uh, I mean, I spent quite a bit of time with these local communities, and it's a very humbling experience where you go in and you describe what you're going to do.
Yeah.
And actually, we were quite surprised by how much they understand of the whole process. But you ask them, what are the things that you need? And they'll say, well, actually, we need water. Like we have this well, but it doesn't have enough water. And we were, well, we are going to need water at our site. Can we just find a way that any water we bring here, we also make sure it passes through your community so you can benefit from it? And so,
Thank you, Thoralf. It's super interesting, but I think we need to
yeah,
actually see if we've got any questions in the chat because I see that we are running out of time.
great.
So let me just get back to the chat here. We have one question here asking what are your like scaling capacity? I think at least O.C.O you touched on it. Sirona, what are you looking at within the next coming 1 year or two?
Yeah. So our goal is to build about 200,000, um, like lower between 200,000 and 1 million tons per year by 2030. And that's sort of like the goal that we have for the coming 5 years. And it's just about building more containers and deploying them to these sites where we have access to the energy and the storage. And in the short term, what we're looking at is in 2026, we're looking at about 1,500 tons that we will deliver to customers. And then that grows about 4x in 2026 to get to about 6,000 tons. And then we just exponentially grow our capture capacity by just adding more containers over time. But
Brilliant.
yeah, that's the range.
Thank you. And what about like do you see any risks with your projects? Peter, do you want to go first?
I think there's risks with any business venture. I think probably I suppose it's not really as much a risk, but I suppose it is in a way. But probably one of the biggest barriers to us deploying our technology is being able to deal with the regulations surrounding the recycling of waste. We're quite lucky in Europe and the EU because we've got the end of waste framework, so we've got a readily established mechanism for us to do that. Other parts of the world don't have that mechanism, or it's at a very early stage. And I think we find that it's quite common that regulatory authorities are quite conservative. So it can be quite a lengthy and costly process to get those regulatory approvals in place.
Yeah, thank you. I think for you actually touch upon this in your presentation.
Yeah.
And like a question that also comes up here is what is like the one myth that you would like to eliminate regarding your project?
Oh, the one myth. Oh, it's a very interesting question. Um, I'm not sure. I'm not sure. I have one if I'm brutally honest.
Well, that's a good one then. Um,
I, I'm happy to go. Yeah. I mean, I think in general, when people think about direct air capture, there's a few things that comes to mind. The first one is, oh my God, this uses too much energy, right? And it's going to emit more CO2 than it captures. Of course, the idea is that we go to places where there is renewable energy so that we can consume renewable energy. And overall, when for every ton that we emit in the process, we're going to capture about 10. So the removal efficiency, as we call it, is definitely there. And then the second thing is people will be worried about, okay, but the renewable energy that you're using, uh, it could have been used for something else that would be more useful. And so
right.
it's important for us to go to places where there's an abundance of clean energy, right? Or that you're bringing new renewable online with your project. And so, for example, that's what we meant with Kenya, 3 gigawatts of supply, 2 gigawatts of demand. This energy is being wasted today. We went to visit the geothermal power plants where they curtail 30% of their energy. And so you basically go there so that indeed there's you're not using energy that could be used for something else. I think usually that's the thing that people think about the most.
Thank you. All right, I see that we are approaching 45 minutes. Thank you both so much for joining and explaining your projects. And if you are interested, someone from the audience, to learn more or actually get your hands on these credits, do reach out, book a meeting, and we will be happy to discuss this further. And with that said, thank you all for joining, and have a great day ahead.
Thank you.
Thank you, everyone.